But yeah, thank you so much for having me. Like Zach said, my name's Dan Finkel. My co-author Luke Belair is also here as well. We're based out of Boston here. We work for a company named SMG, which I'm going to tell you a little bit about as the talk goes on. And I want to talk to you today about location intelligence and specifically this map graphing technique that I'm gonna jump into here. I thought I'd start with a story. Some of you may be familiar with this, but for those of you who are not, in setting is mid-19th century London, the Soho district of London. In the year 1854, there was a really bad cholera outbreak that took place in Soho, London. A lot of people died from the sickness. A lot of people had to flee the area and displaced from their houses. At the time, no one knew what was causing the cholera to be what was causing people to get sick. The city of London was blaming it on air pollution coming from nearby factories. It turns out the hero of this story was a local physician named John Snow, not that John Snow, who was able to connect the outbreak basically to dirty water coming from a pump, a nearby pump or a neighborhood pump in the area. And what's interesting and relevant to this discussion is that John Snow came up with this idea, and then he was able to convince others and prove it to himself, not through biology. There was no biology at the time that linked dirty water to cholera, but instead he used graph and pattern analysis, data science essentially. And this is a historical event in the sense that it was one of the first cases of forensics biology. It's considered a founding event of epidemiology. And so on the next chart, I'm going to kind of show you the data science that John Snow went through to convince himself and others that indeed this pump was the source of the disease. Real quick, a postscript to this story. So after John Snow presented his findings to the leaders, they immediately went and disabled this well. People stopped getting sick. People moved back into the area. Once everything kind of slowed down, the city of London rejected the idea that this well was the cause of the problem and proceeded to turn it back on. And I guess it was because at the time the city of London was not ready to deal with the idea that dirty water carried disease. And so they kind of stuck their head in the sand about that. So what John Snow was able to do through hard work and this graph I'm about to show you was he went through and he plotted out. This is a map of 1850s London. The blue dots here represent all the neighborhood water pumps where people would get their drinking or potable water, and the red dots here represent the houses where individuals died from cholera during this outbreak. And you can kind of see the data laid out here. So John Snow went through and collected all this information. What he then did is he drew on this graph, he drew these partitions, and he broke these regions out by proximity to each of these different water wells. So the idea being that anyone inside this region here, they would, if their closest well was this blue dot that's shown right here, and so on and so forth. And when you draw or place these partitions down, it becomes immediately obvious to the viewer that this well right here is really suspicious. You can see a lot of the red dots cluster inside it. And in fact, what John Snow did was he went out and he interviewed the families of these people as well, and he was able to, in every single case, there was a reason why these individuals were going to this well over here to get their water. And so again, this was the evidence that he used to kind of identify and convince others of what was causing this disease. I think before I leave this, I think there's a subtle but important point for data science to bring up here, in that John Snow the data science in this problem wasn't used in discovery. He had some subject matter expertise as well as some intuition that led him to come up with a theory. He used the data science to help him bolster that theory and convince others of it. And that sort of nonlinear version of the story, we get sucked into sort of this deep learning. I know it's a very big and important area, but I just wanted to kind of remind everyone that a little bit of domain knowledge, intuition, and hard work can really bolster and be used and sort of still very important in the data science arena. So the rest of this talk, though, is going to be focused on sort of this partitioning technique and some of the ways that we at SMG have been able to use it. So really quick, so just that was, as is often the case, there were multiple discoveries of this partitioning technique. John Snow discovered it sort of because he needed it. 40 years later, a Ukrainian mathematician named George Voronoi came up with a formal mathematical declaration of it. Again, what his definition was is you start with a set of points, and then you partition a space, any dimension, such that the distance metric to any point inside its partition is closer to that point, its home point, than any other point, right? So for example, this green region right here, any point inside this region is closer to this well or this location than any other point as well. And what's exciting is this algorithm, this concept is now widely distributed. It's in the SciPy library in Python, and that's what I used for the analysis I'm going to show you. It's fast, it scales to multiple dimensions, works really well. And then if you want, you can get into sort of the numerics, which are pretty interesting, and how these algorithms are implemented. And you actually solve the dual problem. It's been shown to be faster than the initial problem. Voronoi partitions are used. I'm certainly not the first person to try and use them before. They're used in a lot of different applications already out there. I've already been talking to a few people this morning about different applications that they're used. I think the forest canopies is a really neat. That's a really neat way that nature implements and utilizes Voronoi partitions. When putting together this chart, I was relieved to learn that my flight diversion software on my airplane will route me to the nearest airport using these partitions as well. I think that's a great use of Voronoi, and so on and so forth. So it's something that's definitely out and being used. And when we learned about this, we wanted to start applying it to our data as well. Really quick, because we're at a data science conference, I wanted to just mention how easy it is to create or generate these Voronoi plots. It can literally be 3 lines of code. It's in the SciPy library. You can import it from there. You pass it a NumPy array of point locations, and then SciPy even offers a plotting functions where you can see the data come out. What I've done in the analysis that I'm going to show you today is I augmented this just a little bit. This data structure that comes back from SciPy describes or lists the points and edges that are in a Voronoi map. What I want to do is take advantage of a lot of the spatial capabilities that now exist in the world. So I wrote a short script that takes those Voronoi regions and converts them into, I think in this case, shapely polygons. And so that way I can begin to use all the polygonal functionality like overlaps, unions, intersections, and so forth. And I put that up on a GitHub page if anyone's interested in it. Again, it's just a pretty straightforward ability to create these Voronoi regions and then have the polygons that come out of it. Okay, so before I get into my stories or use cases, I wanted to really quick tell you about the data sets that are gonna use that generate some of the stories really quickly here. And to do that, I wanted to tell you a little bit about where I come from and what we're trying to do. So as you can probably tell, this is a marketing chart. It looks a lot different than my other charts. But I just wanted to kind of make the point, at SMG is a measurement company. What we do is we work with major restaurants and retail brands on achieving 5-star human experiences. And we measure that, we measure customer experiences for them and then report that data back to them and describe how customers interacted with their brand or their store and report that out. The motivation for this is something called the service profit chain. It comes from this belief or this idea that was first proposed about 30 years ago or so in a Harvard Business Review paper that a way to generate profits or in the retail and the service space is through this chain. In order to make money, you need to start with highly engaged and happy employees. Highly engaged and happy employees lead to highly engaged and happy customers, and then highly engaged and happy customers will start visiting you more often, they'll spend more, they'll recommend you more often. So a good idea to keep in your head when you think about the service profit chain is the Apple Store, or the Apple experience, and how much effort they put into keeping their customers happy, and what kind of response they get as a function of that. Not everyone believes in the service profit chain. Perhaps your cable company might come to mind as somebody who doesn't necessarily believe in making sure their customers are happy. I'm sure you can imagine your own, but nonetheless, this is something that certainly a lot of companies adhere to, and more are coming around to. At SMG, we get our data to measure the service profit chain through a variety of streams. I have a few listed out here. A majority of our data comes from point of sales receipts, so if you've ever been, I'm sure all of you have had this experience where you buy something and then the clerk at the bottom says, hey, there's a survey, link to a survey at the bottom of your receipt, please go online, fill out this survey. There's a good chance that's us running that result and compiling that data and then reporting it back to that brand. So point of sales receipts, the one I'm going to focus on or talk a little bit about today is location-based mobile. That's something that Lou and I have been working on for the past couple years. So again, another marketing slide just to set things up. I promise I'm not trying to sell you anything today. But just to make this point that the path for us to generating insights and what we're going to talk about today comes from both measurement as well as technology. We invest significantly in both areas. And the data, I'm going to show you a video on this next chart to kind of describe where we're getting our data from.
You can learn a lot from what people tell you.
Let me just really quick. One more time, this was produced by marketing, and I think you'll see that. But it says much better than I can what our product is and where we're getting our data from.
You can learn even more from what they don't. That's the driving insight behind SurveyMini, our industry-leading mobile research app that tells you what your customers and non-purchasers are thinking, what they're doing, who they're buying from, and who they're not buying from. It's based not just on what people say, but what they do. Let's take a look at how it works. This is the SurveyMini app on Jen's phone. She already filled out the one-time user profile. She opted in because it's so easy to share her opinions about the places she shops and dines. And she loves receiving rewards. We know Jen is careful with her money, but we also know she trusts certain brands to keep her looking good. Today after work, she shopped her favorite department store. In a visit detected survey, Jen tells SurveyMini she shopped the apparel and shoe departments, but left without making a purchase. An hour later, in a follow-up survey, she shares that she couldn't find the exact dress and designer heels she was looking for. She also said she intended to shop the department store's website to find the items. However, our visit detection technology uncovers that Jen shopped and purchased at a direct competitor the next day. We also know she didn't visit her favorite department store again for 45 days, but visited the competitor twice during that window of time. The insight? With SurveyMini, we quickly understand if Jen buys more or less than she intends when she visits your store. And when she purchases nothing at all, we know where she goes instead and why. This is Zach's phone. Today, Zach visited his neighborhood chain grocer, where he uses his loyalty card nearly once a week to shop for his family of 5. Through our visit detection technology, we know Zach also shops a big brand health food store twice a month and makes one visit to a club store. Zach reports that availability of specialty items and price are the reason for those extra trips. The insight? With SurveyMini, we know the neighborhood grocer is getting less than 60% of Zach's grocery spend. We also know how far, when, and why he's willing to make a special trip for additional items. SurveyMini uses our proprietary pinpoint technology to accurately map locations and detect visits. We've mapped over 1,500 retail, grocery, C-store, and restaurant brands of all sizes, totaling more than 500,000 locations in every DMA and growing daily. We trigger surveys during or immediately after a visit, and because it's easy, we receive accurate feedback within about 2 hours, while the experience is still fresh. We also know where your customers go before and after a visit, and we have near real-time feedback from your competitors' customers as well. which means our branded benchmarks are second to none. It's the mobile research technology that gets you closer to your customers so you make smarter business decisions. Rich data, real insights, smarter decisions. Find out more about SurveyMini at surveymini.com/demo.
So yeah, as a data scientist, it's really exciting that the world is now carrying around a sensor package in their pocket, and you can pay them for their information and then derive behavioral attributes from that information. So this is pretty cool. I'm not trying to sell you a data set here or insight. What I'm trying to do is get you excited from a data science perspective on the data set we have. So really quick, just to point out sort of the data that we're going to be talking about today. The app's been out for a couple years now. We have a lot of downloads of it. On any given day, we have about 140,000 daily active users who are voluntarily providing us with their location information. We take that location information and run it against a large database of locations, places of interest, POIs. I'm sure I'm going to slip into that acronym here, but large database of where restaurants and retail locations are. We run that data. So I'm getting into the right here. So from those daily active users, we're getting all this location data. We're detecting visits against these locations on a daily area. And then from that, we're able to look at those visits and decide, is that someone who we want to further understand how that visit went and survey them on that. So from here, we're able to combine behavioral data with actual survey information to bring insights. It's a really cool, exciting, dynamic data set. If you'd like to learn more about it or want to talk, I'm very excited to collaborate with this data set or to reach out in any way. So please don't hesitate to contact me regarding this. Okay, so now that we've gotten through that, that's the data we're going to use. I'm going to show you a couple of examples of how we've harnessed this Voronoi partitioning process to derive insights. The first one I'm going to talk about is Major League Baseball. I'm sure many of you are familiar with U.S. Major League Baseball, but just in case, there's a couple of high-level overviews. There's 29 baseball teams in the continental United States. There's 30 teams in the league. I left out Toronto because we don't necessarily get great data from Canada with the app shown there. The Major League Baseball season goes from April to September. For many reasons, it's a nice from a statistical or measurement perspective. There's a lot of games. There's almost a game every single night. Each team plays 81 games at home. And so what I'm interested in doing is looking at those home games and understanding where are their customers coming from as we're going to get into this. So the first thing we can do is we can take that Voronoi code that I showed you earlier and quickly draw out the Voronoi regions for each of these different teams. And you can see they come in all shapes and sizes. The Colorado Rockies, who play in Denver, from a Voronoi perspective, own a huge swath of the United States. Whereas, I don't know, maybe the Padres in San Diego, who are abutted by the ocean, the Arizona Diamondbacks on one side and the LA teams above have a really small region shown here. And you can go on and so forth and walk through all your different, your favorite team or area here. And again, I want to use this data that I just showed you to begin to analyze behavioral patterns for where these teams are getting their customers from. So the first thing we looked at was, where are these guests coming from? So I classified people visiting a team from either coming as a home fan if they're coming from inside the region, and an away fan if they're coming from outside the region. And I looked at the team breakout I've ordered the teams by who's getting the most fans from outside their home region. So at one end of the spectrum, you can kind of see that the Kansas City Royals, they bring in the most fans from their home or region, or the smallest fans from outside that region. And then at the other end of the spectrum, our very own Boston Red Sox here, who they bring in a lot of fans from outside the New England partition that I showed you before. Just out of curiosity, did anyone go to a Red Sox game this week? I know they were in town. Awesome. Are you guys from out of town? Yeah. So it kind of fits, right? It's a thing to do in Boston, and it's certainly reflected in our data. What's pretty exciting as well is after I looked at this insight, I looked up sort of the marketing pitch for each of these different teams. So these are the sort of the Voronoi kind of rough heat maps of the different Voronoi regions of where these fans are coming from. And I don't think I'm breaking new ground here because the marketing for each of these two teams on the extreme reflects this fact in it pretty clearly. This year, the Kansas City Royals marketing is Raised Royal, which sounds very much like they're trying to bring people who are locals and get them into the game. Likewise, the Boston Red Sox market themselves as in a national place, Red Sox Nation, which is certainly interesting and reflective of this data. So a nice kind of interesting validation, I guess, of this Voronoi partitioning and showing that it certainly seems to make sense in the real world. The next thing I did was I looked at the people that were inside that home region, and I measured how far do they travel to get to the stadium. And so the x-axis in this plot here is the size, the area of that region, and you can see on the vertical axis is how far did people travel if they lived inside that region, how far did they travel to come to the game. And it's interesting, the data kind of, there seems to be some exponential decay correlation in the data, I'd argue. I drew this line in myself, but you can kind of see it fits the data reasonably well. There's a couple that kind of jump out that are interesting to me. The two New York teams it appears have much different behaviors in their fans. Looks like the Yankees draw a lot of people directly from the greater Manhattan or New York City area, whereas the Mets, perhaps they're able to pull in more fans from the Long Island or part of New York. I thought that was interesting that there's such a big separation there. Another one that I think is interesting is to highlight is the Atlanta Braves. And the Atlanta Braves, by far, have sort of the largest swath. They're able to, this average distance traveled, they pull in more fans, or have a larger average distance traveled for their home fans than anyone else by a significant number. And if you're familiar with Atlanta and Major League Baseball, you know that they, for many years, were a regional team, and they've built this up over many years. What I think you could take away from this is if you're someone like the Colorado Rockies, who really don't have any competitors nearby, or Minnesota for that matter, you have a benchmark or a bar. You know what's possible. You've seen what Atlanta's been able to do in regionalizing their team. So if I was the Colorado Rockies, I might look at this and say maybe it's worth investing, trying to pull in more fans from Colorado Springs or a little farther away. Maybe there's some opportunity there as well. And then the last thing I did with this data, or in kind of this theme or stream, was I combine the two metrics we just talked about. So the x-axis is this driving distance that we've just been talking about. The vertical axis is how many fans they're drawing from their home region. And you end up with this nice 2x2, and you can break it out and partition it. And I've attempted to sort of label the different areas here. So down in this lower left corner, you see a lot of the two-team markets. So you see like the Cubs and the White Sox are in here, the Mets and the Yankees, so on and so forth. What's interesting to me is that in this region down here where there's the two-team markets, you also have the Padres and the Red Sox, two teams that are one-team markets, but they're behaving like two-team markets. So that might jump out and be interesting to you. And once again, in the regional area, again, you have the Atlanta Braves sort of out here on an island, and maybe a lot of other regional teams could be thinking about how can we better model our ticket sales or our fan patterns to more emulate the Braves as doing this. Oh, and the last thing, too, that you can take away from this, again, I think the Atlanta Braves are well aware of this. They're building a new stadium, if you're not aware, and they're moving that stadium from downtown out into the suburbs. So clearly they know that people driving in from far away is where their fans are coming from and a priority for them, not so much being downtown and getting in people that are in town visiting. So kind of interesting. The last thing I want to show you with this data set was kind of an interesting asymmetry that jumped out at me. So I was looking at these two market cities, so LA, Boston, other places like that, and I was kind of comparing, well, in say, for example, in LA, how many people that live in the Anaheim Angels region are actually coming up and going to Dodgers games and vice versa? And for many of these teams, you see those numbers balance each other out. People that live in the Mets region going to Yankees games is about the same number as people that live in the Yankees region going to Mets game and so on and so forth. One case where that was not balanced was in the DC area. There's two teams in the DC area, the Baltimore Orioles, which play up in Baltimore, the Washington Nationals, which play in downtown Washington, DC. And what you see here is the breakout of where those fans are coming from in these three areas. So the blue is home fans from that home region, green is from that away region, and orange is from that competing rival region. And you can see this stark asymmetry that bears out in the data here. Baltimore draws a lot more fans from the Northern Virginia, Washington National suburbs as compared to Washington, who only pulls a small number of their fans from the Baltimore, Maryland area of the country. Once again, that kind of should make sense. If you're a follower of Major League Baseball, you know that the Nationals are a relatively new team, and so they're still putting their roots down and still establishing their fan base. It's going to take time for them to create fans in the Baltimore area and get them to come down and come to Nationals games. Whereas the Orioles, for a long time, were the only team in town, and people created allegiances to them and are willing to drive up to Baltimore and do that. And again, the message or takeaway here might be different on your perspective. If you're the Orioles, you might realize that, hey, there's a lot of people coming to my games that are now almost literally driving by a stadium to get to Baltimore, and I better be cognizant of that and better make sure I'm taking good care of those people. Likewise, if you're the Washington Nationals, you might take this as a sign that, hey, there's a whole bunch of baseball fans up in Baltimore. Maybe I need to provide more outreach to them and start trying to poach them away from going to Orioles games. So kind of interesting, again, and where a lot of this is harnessed by sort of this, enabled by the fact that I can partition this large space into these different Voronoi regions. Okay, so I'm going to shift from Major League Baseball to talking about fast food. And the use case here that I wanted to talk about was Taco Bell. So I'm sure everyone here is familiar about Taco Bell, but just in case, a couple of fun facts about them. They've been around for about 55 years or so. They were founded in 1962 in California by this man named Glenn Bell. There's now over 6,000 Taco Bells in the United States. According to Wikipedia, they sell over 5 million tacos per day, which is pretty amazing. And first tacos were very cheap. And Taco Bell, your view of their brand has iterated over the years. If you're my age, you probably think of this dog when you think of Taco Bell. If you're younger than me, you're probably more familiar with some of their more modern branding techniques. The map up here is once again a Python script that I just showed you, breaking out the United States into these different Voronoi regions for these 6,000 Taco Bells. And once again, very fast. This is on my laptop. The SciPy library for doing this moves really quickly, and you're able to create these regions really fast and turn them into polygons. Okay. First thing I did was a competitor analysis. So for each of those different regions, I looked at what competitors were in each of those different regions. So for example, in this case, McDonald's, you would find that in each of those different regions I created on the last chart, in 96% of them, there's a McDonald's. And these brands are sorted by store count. So McDonald's has the most stores of all these brands that I've shown here. Starbucks is next, so on and so forth. A couple of things kind of jump out that I think are interesting in looking at things this way. So first of all, you can see the regionality of certain brands. So even though there's a lot more Starbucks than Burger Kings in the world or in the United States, they occupy much fewer of those Voronoi regions that I showed on the previous chart. They're a much more regional brand. They cluster in certain areas that Taco Bell does not. Likewise, Dunkin' Donuts, right? I think Dunkin' Donuts is primarily an East Coast, although growing, but is primarily clustered on the East Coast. So those asymmetries are interesting and they bounce around. Another interesting thing to me that, or maybe a takeaway perhaps for this, is you begin to understand the regionality of a lot of these different brands. You can, for example, you can tell if Arby's started selling tacos, it's going to directly affect about half of all the Taco Bells out there in the country. Whereas if McDonald's started selling tacos, it's a much bigger deal to Taco Bell. And you can also you could go back and you could identify which of these specific regions are vulnerable to each of these different brands. You can see that as well kind of play out here. But definitely it definitely gives you an appreciation of how widespread Taco Bell has become and how large they are. This next chart, what I did was I generalized those brands, and so just plotted the intensity on this plot here represents how many of those competitors are in each of these different regions, and it's shaded by the indices shown here as well. So the darker the region gets, the more competitors are in that region. And then you can take that data, those counts, and rapidly produce a histogram of competitors in each of those different Voronoi regions, right shown. You get this nice looking histogram shown on the right here, and you can pull from that an average of 10.5 competitors. So in each of those on average, in each of those 6,000 Voronoi regions we computed, there's about 10.5 different competitors from the brands I showed on the last chart. So this got us thinking, well, what else can we, so this is an interesting metric, measuring how many competitor brands are in the same region as a Taco Bell. Started wondering what else could we compare that with. So one of the first things we looked at was computing the population of each of those regions. And so once again, because we've converted those regions into polygons, it's very easy to take US Census data, pull it down from their API, and intersect those polygons with the polygons provided by the Census Bureau and come up with population estimates for each of those regions. So that's this horizontal axis here is the population of each of those regions. The y-axis, again, is those competitors that I showed. The intensity reflects the number of stores that are captured in each of those bins. What's kind of interesting here is you can see there's some structure in this data. So you see this sort of slope in this blob. Certainly, that's to be expected. You would think that the more people there are in a region, the more draw there is of brands and store locations to that. And what I thought was interesting, what you could begin to do is you could break this out into a 2x2, and you could begin to label the different spaces. So imagine yourself as an executive at Taco Bell, and you're trying to understand where do I want to put more stores. You could look at this data, and you could begin to label these different areas as interesting places. So for example, stores where there's a lot of people and few competitors, those might be candidate locations for some place where I want to break up that Voronoi diagram and throw another store in. Whereas areas where there's few people and lots of competitors, that's probably a saturated market and somewhere that I don't need necessarily need to bring in more stores. And likewise, you can kind of walk around this quadrant and labels. These labels are mine only. Certainly, you could imagine some brand strategies might be different, where perhaps I do want to go put a store somewhere where there's lots of competition and lots of people, right? There's people that already have behavioral habits of going to a place to get food, and I want to take advantage of that and put my store there. So not necessarily the right strategy, but certainly a strategy to way to look at this data. And then what you can do is you can turn around and plot this data back. You can, if you come up with different, I just attached different colors to these 4 quadrants, and then plotted the data back on the map. And so you can begin to, this is a nice way of visualizing sort of what these different regions are. And for example, if you believe this color scheme, Taco Bell might look and say, oh, look, Seattle is an area ripe for opportunity for us. There's a lot of people there that aren't being serviced by a lot of fast food chains. Maybe we should look into investing in that area. So the last thing with this data that I wanted to show was you don't have to stop with 2D or 2 dimensions here. So one of the things that we're trying to do with this data is expand it beyond. So another thing you can do, another great data source, if you're not already aware, is the Bureau of Labor and Statistics publishes unemployment data. A very nice API to pull that down as well. And you can come up, in this case, I did the same thing as we did with the population data where I histogrammed the unemployment of the county in which each of those stores are in. And while maybe not the best way to visualize this, I thought it was an interesting, the bug splat plot here on the right, kind of you can take these 3 features that we've now started to look at, population, unemployment, and competitors in the Voronoi region, and you can really begin to start labeling and categorizing these different stores this way. And you can also imagine maybe you might want to combine these 3 metrics into a single statistic. So for example, if you're Taco Bell, maybe you're interested in characterizing the hiring environment. I go back to earlier, I was mentioning it's really important for these, we believe it's really important for these brands to maintain strong associates and strong teams in their stores. So you might want to identify stores where there's, I'm going to get this wrong, so there's low unemployment, few people, and lots of competitors. That's a really difficult hiring environment for Taco Bell, for example. And that store position there, maybe they need extra resources to keep their associates happy and at their store. Whereas the converse of that statement, maybe that's a really easy hiring environment for a store, and they need to make sure that they have a top-notch staff, because if not, it's very straightforward for them to replace them. So again, all enabled by these Voronoi partitions in regions. Yeah, so that's really what I wanted to come and tell you about. I believe in the broader sense that location intelligence is this rapidly growing data science application. I've certainly experienced this coming over from the physical sciences into this more behavioral sciences. Again, because of the data sets that are starting to come online, all these techniques that we were using in the physical space, classification, detection, so on and so forth, we can now begin to apply to behavioral problems. And location intelligence is a great application of that. And there's a thirst for brands, and in my experience, they want to understand their customers. Everyone wants to take the Amazon model of understanding their customers and apply it in the physical world. And so this need for understanding your customers and their behaviors is really important and very high buzz these days. I really, this was all, I was excited, again, this Voronoi partitioning really enables a lot of this analysis. It creates these natural partitions of space, and certainly the data seems to suggest that they accurately capture people's behaviors. And yeah, I think that's about it for me. Thank you again so much for listening and coming. Okay, awesome. I didn't hear the first part of the question. Buffers. Oh, so the question was, am I using buffers, and how does this work? I think in a dense area like New York City was the question. I think it's gonna. So I'm not using buffers for the analysis I showed you. Maybe that's something I should think about doing. I do think there are challenges in using something like this in a place like New York City, where people's behaviors aren't dictated by proximity. You know, you can imagine instead of a straightforward distance metric, in New York City, you need to think about trains and other things. That being said, I do think in New York, I don't know how many people, for example, I think when you grocery shop in New York City, you probably still go to somewhere relatively close to you. You're probably still incentivized to do that. Either you're walking or you're renting a car. And so I haven't tested in New York, but I suspect there's still some correlation with the distance metric. Yeah. Only, so the question was, does the data that we collect, is it everyone who visits a store or only who's signed up? So for the data sets I showed you, it's only people who carry around the app, so it's a subset of the people. And also when we collect point of sales receipt survey data, again, that's only people that A, made a purchase, and B, went to the trouble to fill out a survey. So only subsets of data for what I showed. Yes, sir.
In your hardware analysis, you collected a lot of location data in stores.
Yeah.
Where did you collect that?
Yeah, so that's a good question. So the question was, I showed a lot of location information, right? I knew where all 6,000 Taco Bells were, and I also knew where all their competitors were as well. We've employed a lot of, this is an unsatisfactory answer, and maybe we can talk offline, but we've employed a lot of proprietary tools and techniques to compile that data in that database. It's one of the really powerful data sets that our company has.
It's not using one database. You collected a lot of various.
Yeah, our company invested and built that data set. Yeah. Yes, sir. Yes, sir.
But in reality, of course, the transportation network doesn't look like that.
Yeah.
So have you done it the other way, or why would one do this, given the fact that we have data on metropolitan areas and tribal zones?
Yeah. So the question was good insight is that I used a Euclidean metric for all this analysis, and the honest to goodness answer is it's easy. But none of this is precluded by the fact that if you understood if you wanted to apply a taxi cab metric in New York City, for example, you could certainly do that. We just we're not there yet in terms of the analysis. And we are also looking at a very macro sense. I think as you drill down into smaller areas, that would become a lot more important and would help out a lot, absolutely.